Okay, today we're going to be going over how to write the equation of a transform function. This is for the Unit 5 Honors Study Guide review question. So first thing you have to do is figure out what shape are we talking about. So if we look at this shape, whenever we have this restricted domain with the starting point and the curve, this is a parent function of the square root of x. So its transform function will be of the form a square root of x minus h plus k. So we want to figure out what is that a, h, and k. So the first thing I need to identify is my h and k. Your hk for a square root function is always this starting point of the graph. Okay, wherever that graph starts, that point is your h and k. So on this first one, my hk happens at -1, comma, -5. On this one, it happens at 1/2, comma, 1. So that's my h and my k. There's my h and my k. So I'm going to do the one on the left first, then I'll go back and do the one on the right. So now that I know my h and k, I'm going to go ahead and plug it in to my function. So I get g of x equals a, the square root of x minus -1 plus k. All right, now what I need to do is I need to pick another x and y on the graph, any other x and y, and that will be my x comma g of x, and that will allow us to solve for a. And so I look, and there's a couple different points. I could use this one. I could use this one. I could even use up here. Okay, so you can use any of these, but this one I'll go ahead with because it's going to get us the smallest values since it's closest to the h and k. So that's at 0, comma, -2. So that I'm going to plug in for x, comma, g of x. So I replace g of x with -2. I don't know what my a is, and I get the square root of 0, and minus -1 is +1, minus 5. Our goal here is to solve for a. So the first thing I'm going to do, I want to get rid of this subtraction here. So I'm going to add 5 to both sides. -2 plus 5 is 3. And under the square root, 0 plus 1 is 1. Well, what is the square root of 1? It's 1. So I get 3 equals 1a. But 1a is the same as if I said just a. So in this situation, a equals 3. So to write my final answer, I'm going to go back to my g of x setup up here, and I'm going to replace the a. So I'm going to get g of x equals, now instead of saying a, I say 3, the square root of x. It's supposed to be minus -1, so I'm going to write that as +1. And on the outside, I have -5. And there we go. All right, next we're going to look at the second equation over here. All right, so I'm going to clear this, and we'll do it for the one on the right. All right, so now we're doing it for the one on the right. So I have g of x equals, I don't know what a is, the square root of x minus h, which is 1/2, plus k, which is 1. And so now I pick another x and y on the graph. So this one here, this is 1.5. So that's 1.5, comma, half. So I'm going to replace my g of x with 1/2. And that's going to equal a, the square root of 1.5 minus half, all of that plus 1. All right, so the first thing I'm going to do is I'm trying to get a by itself, so I subtract 1 from both sides. And if you have 1/2 minus 1, that's negative half, equal to a, and then 1.5 minus a half is just 1. 1.5 minus half is just 1. Well, the square root of 1 is 1, and 1a is just a, so negative half equals a. So I'm going to go ahead and write my final equation as g of x equals negative 1/2 the square root of x minus h plus k. All right, the next two are a different parent function. The next two are a different type of parent function. So if you look at these two, and I will have to scroll through separately for them, but if you look at these two, notice they're kind of the sideways squiggle. So when you see this sideways squiggle like that, that looks like the parent function of the cubed root of x, and that's because they are. So these bottom two, the parent function is, x cubed, they're the inverse of x cubed. The parent function is the cubed root of x, and so its transformation will be a, the cubed root of x minus h plus k. So same kind of structure, just a new parent portion at that cube root. All right, so I need to identify my h and k first. When it's these cube roots, you want to look for where it changes from curving down to curving up. That spot where it switches its type of curve from curving up to curving down, that's my h and k. So there is my h and k right there. So this one's counting by 2, so that's at -2, -2. All right, so be careful on cubics. You're looking for where they're switching that curve. So I'm going to get g of x equals a, the cubed root of x minus -2 plus -2. Now I need to pick another point on the graph. I'm going to go ahead with this point because it's in a corner. And so this point is 6, 4. So I'm going to go with 6, 4 as my x, g of x. And so I get 4 equals a, the cubed root of 6 plus 2, all minus 2. Same as last time, we want to get the a by itself, so I want to get this term by itself, so I'm going to add 2 to both sides. 4 plus 2 is 6. So I get 6a, the cubed root of 8. So cubed root of 8, you have to ask yourself, what multiplied 3 times is 8? And that would be 2, because 2 times 2 times 2 is 8. So the cubed root of 8 is 2. So 6 equals 2a. To get a by itself, we divide, and 3 equals a. So now I go and I write my final equation as g of x equals, my a is 3, the cubed root of x, and then we had plus 2, I'll subtract 2. Notice my k is always outside the radical. And I do want to see you writing your transform function as g of x equals. All right, so use it when it says function notation, it's looking for you to use this function name in front. All right, so this one, again, the biggest challenge most people have on these is figuring out where h and k is. So I look for where the curve changes, and then it changes to up right there. So my h and k is at 2, -6. So I'm going to get g of x equals a, the cubed root of x minus h plus k. And now I need to pick x comma g of x. Okay, so I have several different options here. Pick whichever one you're most comfortable with. Okay, I'm just going to go with this one on the very right, which is 10 comma negative 10, 10 comma negative 10, and that's my x comma g of x. So I get negative 10 equals a, the cubed root of 10 minus 2, I'll subtract 6. First thing I'm going to do is get rid of the subtract 6, so I'm going to add 6 to both sides to get negative 4 equals a, the cubed root of 8. Well, the cubed root of 8 again is 2. So negative 4 equals 2a. I'm going to divide both sides by 2. And negative 2 equals a. So now I get g of x equals negative 2, the cubed root of x minus 2, all subtract 6. Notice this time my a was negative. And that's because if we look, this actually flipped. This was a reflection. Our normal parent cubic comes off from 0 like this. And so that one is flipped over. It's a reflection. So that's why the a ended up negative. And it was moved to the right 2 and down 6.